Good afternoon, everyone. I am Rosemary Palmaria with Miss Jean Carla Guara and Mr. Ronald Encinas. We will now discuss the data mining algorithms. An algorithm in data mining or machine learning is a set of heuristic and calculations that creates a model from data. To create a model, the algorithm first analyzes the data you provide, looking for specific types of pattern or trends. A calculation in data mining is a bunch of heuristic and estimations that makes a model from information. To make a model, the calculation initially breaks down the information you give, searching for explicit kinds of examples or patterns. The calculation utilizes the after effects of this examination over numerous emphasis to track down the ideal boundaries for making the mining model. These boundaries are then applied across the whole informational index to remove noteworthy examples and point-by-point measurements. Moving on to the prediction. It is a data mining technique that can be used to extract a model and represent the data classes in order to predict future data trends. Prediction can be defined as the output of an algorithm after it has been instructed to operate on a historical set of data and then it is applied to new data. So, prediction is an information mining method that can be utilized to separate model and addresses the information classes to anticipate future information patterns. Forecast can be characterized as the result of a calculation after it has been told to work on a recorded arrangement of information and afterward it is applied to new information. For instance, determining the weather conditions is the most famous illustration of information mining's expectation. At the end of the day, it will likewise be characterized as a gauge of a prediction. One more illustration of a forecast can be a mystic telling an individual his or her future.
Statistical Bayesian classification. Bayesian classification is probabilistic approach to learning and interface based on a different view of what it means to learn from data, in which probability is used to represent uncertainty about the relationship being learned. Bayesian classification is probabilistic way to deal with learning and deduction in light of an alternate perspective on learning from information, in which likelihood is utilized to address vulnerability about the relationship being learned. Before we have seen any information, our earlier conclusions about what the genuine relationship may be are communicated in a likelihood conveyance. After we take a gather of the information, our change assessments are caught by a back circulation. Bayesian learning can create the likelihood appropriations of the amount of interest and settle on the ideal choices by thinking about these probabilities along with notice information. Bayesian networks. Bayesian networks are graphical models that contain information about causal probability relationships between variables and are often used to aid in decision making. Bayesian networks are graphical models that contain data about causal likelihood connections among factors and are frequently used to support direction. The causal likelihood connection in a Bayesian organization can be recommended by a specialist or refreshed utilizing the bias hypothesis and new information being gathered.
Instance-based learning refers to a family of techniques for classifications and regression, which produce a class label or prediction based on the similarity of the query to its nearest neighbors in the training set. So, instance-based learning refers to a collection of order and relapse procedures that generate a class mark or prediction based on the increased similarity to its nearest neighbors in the preparation set. In contrast to other strategies such as decision trees and brain organizations, occurrence-based gaining computations do not take explicit occasions into account. Rather, they just store all the data and when it comes time to ask a question, obtain an answer from the inquiry's nearest neighbors. Linear models are a way of describing a response variable in terms of a linear combination of predictor variables. The response should be a continuous variable and be at least approximately normally distributed, but cannot handle clearly discrete or skewed continuous responses. So, linear models are a way of representing a response variable in relation to a straight mix of indicator variables. The response should be a constant variable that is basically normally allotted to some extent. Such model can find a wide range of applications. However, they can't handle discrete or tilted consistent responses. GLMS summarized direct models enable the extension of straight showing thoughts to a broader class of reaction kinds such as count data or twofold reactions. There are several quantifiable ways for such data kinds, but the GLM approach has the advantage of combining a seemingly diverse set of reaction types under a common presenting mechanism.